Chemistry students, this is a little quick video on heating and cooling curves. Okay, so they're kind of just what they sound. Basically, a heating curve would be if you heat a substance from a solid state all the way up until it's a gas. So you got to heat it as a solid, get it hot, eventually it turns into a liquid and melts. Heat it far enough, that liquid starts to boil, it evaporates, turns into a gas. So that's what a heating curve is. So heat is called thermal energy. Heat is thermal energy. And remember, that's energy of motion. Okay, heating, if you heat molecules, they start to move faster. They get more kinetic energy. Kinetic energy is energy of motion. So as you heat them, they get more kinetic energy. So here's a little graph. This is just temperature, so cold to hot. Cold to hot. Maybe this is 0 degrees down here. Celsius, we'll say we're in. Down here is 0 degrees Celsius. Maybe up here is 200 degrees Celsius. Okay, and this is just time as we're adding heat. So say we're putting an object as a solid on a stove, keeping it at the same, adding the same amount of heat the whole time, so not changing that temperature of the stove, but you're continuously adding heat to that substance. And it's just what the graph would look like. Now, if you sketch this, you would think, okay, let's say my solid is at, let's say we're starting off with a solid that's at 5 degrees, and you start to heat it. Okay, you start to heat that solid until it turns into a gas. Most people, if I say draw this curve, they would draw a curve like this, where it just gets hotter and hotter and hotter continuously. Okay, it's sitting on the stove, so the object just keeps getting hotter and hotter. In real life, that's not what happens. If you put a thermometer in and measure it, that is not what happens. Okay, some people will do this in some classes with ice. Okay, all the way up to steam, and it's not what happens. So first thing, when you start heating a solid, it does get hotter. Okay, you start heating it does get hotter. So those molecules begin to speed up and spread out as they get hotter. So the first part of the graph, as you start heating it, it is getting hotter. Temperature is going up. You get to a certain spot, though, when the molecules start to melt. Once those molecules start to melt, so once they've gained enough kinetic energy, so this is an increase right here, an increase in what's called kinetic energy. The particles are moving faster. They're speeding up. So once you've added enough heat there, and this is a solid, you heat it. Once the molecules start to melt, the temperature no longer changes. You're still adding heat in, still adding heat. So if a piece of ice, you still add heat to it. But while it's melting, that temperature stays the same. While it's melting, that temperature does not change. So as it is melting, however long that takes, as it is melting, that temperature levels off. Even though you're still adding heat, but all of that heat energy is going into making the molecules spread out enough to turn into a liquid. Okay, and that's called an increase in potential energy. So you're still adding heat in, and you're increasing what's called potential energy or stored energy. Eventually, those molecules all get enough energy, they're all liquid molecules. So right here, you would have some solid and some liquid molecules as it's melting. Some are solid, some are liquid. Once they all become liquid, the temperature starts to rise again. So again, we're still adding heat the whole time. We didn't stop adding heat right here, but the temperature levels off. So then we get to here. And the temperature will start rising again. So we're adding continuous heat. Everything right here is now a liquid. So from there to there, everything is a liquid. Okay, and it's just a liquid getting hotter. So again, you're increasing the kinetic energy of the particles. They're getting hotter, moving faster. Kinetic energy, that's supposed to say kinetic energy. It's hard to see that. Increase in kinetic energy, which is energy of motion. So the molecules are speeding up, spreading out, moving faster. Once you get to a certain temperature, you start to see bubbles. That would be the boiling state. So everything starts to boil. Okay, so once it starts to boil, again, it starts to level off. If you put a thermometer in boiling water, even though your stove might be at 500 degrees, that water stops at 100 degrees Celsius and stays at 100 degrees Celsius the whole time it's boiling. So it doesn't matter how hot your stove gets, your boiling water will only get to 100 degrees Celsius, and it will stay at that temperature until it boils completely off. So right here, we are boiling. Okay, or vaporizing. So this is vaporization. which is just boiling. You would have some liquid and some gas molecules. And you're still adding heat. You're sitting on a stove boiling water. You're still adding heat, but that temperature is staying consistent. That's an increase in potential energy, stored energy. The energy is being stored in those molecules till they get enough energy to turn into gas. Once they all turn into gas, now start to heat up again, and this would be your gas state, getting hotter. If I asked you what your boiling temperature was, just come across this line. Whatever's right here would be your boiling temperature. So maybe in this case, it's 150 degrees Celsius, somewhere in there is the boiling point of that substance. That's what temperature would boil at. So again, as you heat a solid, you heat it, gets hotter, increasing kinetic energy, molecules moving faster. Once they start to melt, the temperature levels off and stays that same time. So this would be the melting temperature right here. Whatever this is right here, maybe this is 30 degrees Celsius is the temperature this thing melts at. Obviously, it's not ice. That's not what temperature ice melts at. While it's melting, the temperature stays consistent, even though you're still adding thermal energy, still putting heat in, increasing stored energy. Once everything turns into a liquid, now it starts heating up, increasing kinetic energy. Your molecules are moving faster. Get to a certain point, the temperature will level off and starts to boil, even though you're still adding heat the whole time. Let me show you one other one. So here is a cooling curve. Okay, here's a cooling curve. So now we're starting with the gas, and we're taking heat out, we're removing heat. Okay, we're cooling it. So we're cooling this gas. So right here, the gas is getting colder. That's a decrease in kinetic energy. Molecules are moving closer together. Once you get to right here, those gas molecules are getting close enough together, they're starting to turn into liquids. So this would be some gas molecules and some liquid molecules. Okay, so that would be condensation. Again, you would be decreasing potential energy there. Once you get to right here, all the molecules are now liquid. The liquid's getting colder. That's again a decrease in kinetic energy as you're going down this. You get to right here, and the substance is starting to freeze. It's going from a liquid to a solid. So right here, you'd have some liquid and some solid molecules. Once you get to right there, they'd all be solid. Okay, and this would be freezing. If I ask you the freezing point of this substance, you would say it's about 20 degrees. That's also the melting temperature. Anything above 20, it melts. 20 and below, it freezes. If I ask you what the condensation temperature is, or vaporization or boiling temperature, it's about 75. 75 degrees starts to boil, and above that would be boiling, okay? And then anything below that, the gas is starting to condense back into a liquid. So remember, as a substance is changing state, as it's boiling or condensing, freezing or melting, the temperature levels off. Even though you're still taking heat out or adding heat, the temperature levels off while it's changing state. All right, that's heating and cooling curves.